Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Before I start, let me introduce myself. My name is Yasmin Fatimah with ID number 41014200137. Today I will going to discuss about simplex problems. Then we will discuss the duality and check whether it is a degeneracy or not. And the last one is we discuss three cases of sensitivity. So here I have a problem. Maximize objective function c equal to 6x1 plus 8x2 plus 4x3 with constraint x1 minus x3 less than or equal to 2, x1 plus x2 plus 2x3 less than or equal to 10, and x1 plus 2x2 plus 2x3 less than or equal to 8, and where x1, x2, and x3 is greater than or equal to 0. The first thing we have to do is to make the standard form. In the constraint, we have a sign less than or equal to. So because of this sign, we need to add a slack variable in the standard form. So we will have x1 minus x3 plus s1 is equal to 2. And we did the same thing to the other two constraints. So we will have for the constraint 2, we will have x1 plus x2 plus 2x3 plus s2 is equal to 10. And x2 plus 2x2 plus 2x3 plus s3 is equal to 8. And for the objective function, the first thing we have to do is move the variable here, the 6x1 plus x2 plus 4x3 to the left side. So we will have z minus 6x1 minus 8x2 minus 4x3. And because in the constraint standard form, we add a slack variable. So in objective function, we add a slack variable too. And next, we make a table that contains basic variable x1, x2, x3, s1, s2, s3, right value, z, s1, s2, and s3. And we will fill this table with the coefficient of the constraint and the object function. For example, here we have that the coefficient of x1 is minus 6, so we put minus 6 here, and so on. And as we can see, there is a negative value in the objective function. So we need to do an iteration. To do the iteration, the first thing to do is to decide what column is the key column. So for the maximized problem, the key column is column with the smallest number, that is minus 8. So the key column will be x2. And the next one, to determine the key line, we calculate index first. The formula of the index is right value divided by the number in the key column. So, for example, we have this 2 will be divided by 0, and that is equal to undefined, and 10 divided by 1 equal to 10, and 8 divided by 2 is equal to 4. And get this result here. And to determine the key line, we choose the smallest number that is greater than or equal to 0. And because of that, we choose 4 because it is smallest and less than 10. So the key line is S3. And also, we will get that the key number is equal to 2. And next, we make the table. Basic variable is the same as before, but the difference is because S3, X2 is into S3, so we change the basic variable here from S3 to X2. And from the key line, first we need to make a new line from the key line, the previous key line. To do that, the number before, the previous number is divided by the key number. So we will have 1 divided by 2 is equal to 1 over 2, and then 2 divided by 2 equal to 1. So we will get, and so on, then we will get this line, new line. And then for the next three is, the formula is the same. For example, I will show you here. For make this new line, we, from the previous value, that is 1, is previous one 1, and then minus the new number in key line, the previous key line, that is 1 over 2. So 1 minus 1 over 2 times the number in key column, the previous key column, that is here. So 1 over 2, I'm sorry, so 1 minus 1 over 2 times 1, or you can see the block here. So 1 minus this cells, this value in the cells, 1 over 2 times 1, and so on. So we'll get this number. And as you can see here, there is still a negative value. So we did another iteration. So because it is the last negative value, this is, we can conclude that this is the key column. And next we determine the key line with the index, calculate the index first. 2 divided by 1, 6 divided by 1 over 2, and 4 divided by 1 over 2. So we will get this index, and we will get the key line, that is S1. And after the iteration, we will have this formula. We will have this table. I'm sorry. And as you can see here, there is no negative value, so we know that this is optimal, and we can conclude that the optimal solution of this objective function is 36. Okay, we move on to duality. So the previous one, we have a primal maximize here, and then we make the dual. To make it easier, we make a table that contains x1, x2, x3, and y1, y2, y3, z, and w. So we put the coefficient here in this table from the previous problem. So x1 from the constraint 1, we have the coefficient is 1, and then x2 0, then minus 1, and the right value is 2, and we will get this. So for the dual, the constraint, we read it from here to down here. If primal, we read it, the constraint is right here, and then for the dual is right here. So we will get that the constraint, there are three constraints, that is y1 plus y2 plus y3 is greater than or equal to 6, and 0y1 plus y2 plus 2y3 greater than or equal to 8, and minus y1 plus 2y2 plus 2y3 greater than or equal to 4. And what about the objective function? So the right value in the primal problem will be, in the constraint, will be the objective function in the dual. So we will have w minus 2y1 plus 10y2 plus 8y3. And same as before, we make the standard form to solve the problem. Because the sign in the constraint is greater than or equal to, so we need to add a select variable, then an artificial. So an artificial variable, so we will have y1 plus y2 plus y3 minus s1 plus a1 equal to 6, and so on. And then we will get for the constraint 2, y2 plus 2y3 minus s2 plus a1 equal to 8. And for the third constraint, we will have minus y1 plus 2y2 plus 2y3 minus s3 plus a3 equal to 4. And then we make this equation into an a equation. So we move another variable beside a to the right side. So we will have a1 is equal to 6 minus y1 minus y2 minus y3 plus s1. For a2, we will have a2 equal to 8 minus y1 minus 2y3 plus s2. And for a3 is equal to 4 plus y1 minus 2y2 minus 2y3 plus s3. And for the objective function, because we add a select variable and artificial variable to the standard form of the constraint, so we add it 2 to the objective function. So we will have 2 minus 2y1 plus 10y2 plus 8y3 plus 0s1 plus 0s2 plus 0s3 plus ma1 plus ma2 plus ma3. Previously, we already calculate a1, a2, and n3, and then we will substitute this 3 to the equation of the objective function. And then we will have, we will have w minus 2y1 plus m plus 4m minus 10 y2 plus 5m minus 8y3 plus ms1 minus ms2 minus ms3 is equal to 18m. And then it's the same as the primal. We put the coefficient in a table, and the basic variable is w, a1, a2, and a3. And we will have this table. Same as before, we determine the key line, the key column, and then we determine the index and we determine the key line. How did we determine the key column? So to solve the minimum problem, we use a big M method. And this big M method, we determine the key column by the greatest M, coefficient of M. So we have 4M here and 5M minus M minus M minus M. So the greatest one is 5M, right? So we choose this column as a key column. And we will get this table, the new table. And the M is still positive. There are still positive M. So we did the iteration again and again until here, until 2 iteration. From this problem, we get from this iteration, from this table, we get that the optimal solution is 36, and it is the same with the primal problem. Yeah. Next, we determine whether there is a degeneracy or not. To check the degeneracy, we check the index. As you can see here, we have a different index. And from the duality also, we have a different index that there are no index that has the same value in one table. So we can conclude that the problem is not a degeneracy. Next one, we will discuss the sensitivity. The first sensitivity is for change the right-hand side of constraint 1 to 20. So from the calculation before, we have that the basic variable here is x1, x2, and x1, x2, and x2. So we have the coefficient here of x1, x2, x2 from here, x1, 1, 1, 1, x2, 0, 1, 2, and s2 is 0, 1, 0. We will get this. So we have this, and then we inverse this. So we need to find b inverse. We will get this. And we need to check the sensitivity first. And that is, we calculate the b inverse times the coefficient of x1, the coefficient, the right-hand side of the constraint. From the problem here, originally we have the constraint is 2, the right value of the constraint is 2, 10, and 8. Because the problem is change the right-hand side of constraint to 20, so to check the sensitivity of C1, we change 2 to 8, and it is 10 and 8, and then we calculate this. So 1 times 8 plus 0 times 10 plus 0 times 8, and we will have 8. And so on, we will have a greater than or equal to 0, minus 1 over 2, a plus 6 greater than or equal to 0, and minus 1 over 2 plus 4 greater than or equal to 0, and we will have a greater than or equal to 0, a less than or equal to 3, and a less than or equal to 2. So if we conclude from here, we can conclude from here that the range of a is from 0 to 3. And because to 20, because the question is to change it to 20, 20 is outside the range because the range of a is just from 0 to 3. So we need to do the iteration again from the beginning, but the difference is we input the right value of S1 is 20, not 2. And after one iteration, 2 iteration, we will get that the optimal solution is changed from 36 to 48. So it is changing the optimal solution. And optimal solution, because of the change the right-hand side of constraint 1 to 20, make the optimal solution become 48. We move on to sensitivity 2. The second case is added new variable. So the new problem is we have to maximize c equal to 6x1 plus 8x2 plus 4x3 plus 12x4. So we add a new variable x4, and the new constraint is x1 minus x3 plus 2x4 less than or equal to 2, and x1 plus x2 plus 2x3 plus x4 less than or equal to 10, and x1 plus 2x2 plus 2x3 plus 4x4 is less than or equal to 8, where x1, x2, x3, and x4 is greater than or equal to 0. It's the same as before. We make the standard form first. So we will have the minus 6x1 minus 8x2 minus 4x3 minus 12x4 plus 0s1 plus 0s2 plus 0s3 equal to 0. Why there is a slack variable? Because in the constraint we add a slack variable. The standard form of the constraint is x1 for the first constraint is x1 minus x3 plus 2x4 plus s1 is equal to 2. The second constraint, x1 plus x2 plus 2x3 plus x4 plus s2 is equal to 10. And the last constraint is x1 plus 2x2 plus 2x3 plus 4x4 plus x3 is equal to 8. We need to calculate the coefficient of the objective function first. And the formula is CBV times B inverse AJ minus CJ is equal to ZJ. The CBV, or the coefficient of the objection function of the problem, is from the previous. We can see that the basic variable is x1, s2, and x2. So we determine that it is the coefficient of the x1, s2, and x3. So here, the coefficient is 6, 0, and 8 times the B inverse. We already calculate it here, so we just copy it. This, we will get this, and the AJ is the coefficient of the new variable, that is 2, 1, and 4. And we subtract it by the coefficient of the new variable in the objective function, that is 12, equal to objective coefficient of x4. And we calculate this first, we will get 2, 0, and 4. And then we calculate it by this, and we will get that 4 plus 0 plus 16, that is by 2 times 2 plus 2 times 1 plus 4 times 4. So we will get it like this, or equal to 20, and 20 times 12 is equal to 8. Because it is, then we will get that the coefficient of objective function x4 is 8. Because it is positive, then we don't need to proceed the iteration again, because it is the same. And next, the last case, added new constraint. So we have a new problem here. The difference from the primal problem is just a new constraint. So from the original problem, we just have 3 constraints. For the last problem here, we have 4 constraints. We did the same as before to make the standard form, and then the standard form of the objective function and the constraint. And because the sign is less than or equal to, so we need to add a slack variable to the constraint and the standard form of the constraint and the standard form of the objective function. So we will have z for the objective function, z minus 6x1 minus 8x1 minus 4x3 plus 0s1 plus 0s2 plus 0s3 plus 0s4. There is a s4 because there is a new constraint. And for the constraint, the standard form of the constraint is x1 minus x3 plus s1 equal to 2. And the second constraint, x1 plus x2 plus 2x3 plus s2 equal to 10. And the third constraint, x1 plus 2x2 plus 2x3 plus s3 is equal to 8. And the last constraint, x2 plus 6x3 plus s4 equal to 9, where x1, x2, x3, s1, s2, s3, and s4 is greater than or equal to 0. We make a new table, the difference from the previous table. So in here, we just have until s3. But in here, we have s4, we need to add new line and new column s4. For the line, we have 0, 1, 6, 0, 0, 0, 1. And the value is 9. And for the column S4, it is 0, 0, 0, 0, and 1. And we calculate this by the elementary row operation. to make the value in the basic variable, that is x1, x2, and s2 is 0. So we have here the x1, the coefficient of x1 and s4 is already 0, so we don't need to calculate that. And here, the coefficient of x2 and s4 is equal to 1. We have to make this 0. So we did the elementary operation, that is x4 is minus line x2. So 0 minus 0, 1 minus 1, 6 minus 1.5, 0 minus 0.5, 0 minus 0, 0 minus 0.5, and so on. And we will get the new value. The rest of the value is not changing, so we just copy it from the previous here. It's the same with this. So we just need to change the value here. 0, 1 minus 1 is 0, 6 minus 1.5 is 4.5, and 0 minus 0.5 is equal to 1 to 0.5, I'm sorry, and then 0 minus 0, 0, and 0 minus 0.5 is minus 0.5, and 1 minus 0 is equal to 1, and 9 minus 3 is 6. As you can see here, the coefficient of x1 is s4 is already 0. The coefficient of x2 in s4 is equal to 0, already 0. And the coefficient of s2 in s4 is already 0. So we stop here, and then we can conclude that the optimal solution is 36 and is not different with the original problem. Okay, that is all for my explanation. I'm sorry for any mistake. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.